So let's make three tables for position, velocity, and acceleration. Okay. So we're gonna understand the first one. We're gonna understand everything we did from position, displacement, velocity, acceleration, and then the next one we're gonna learn how to find the position function. Okay. So let's draw that. Let's draw a table. Let's say we have 10 units, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And let's extend it in negative region. And let's say we have 1, 2, 3, 4 units here. Okay? And now say this is 0, this is negative 1, this is 1, 2, 3, 4. Right? So let's see. We're gonna make this look like a rectangular box many. Okay, so now here is 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is 10, right? Okay, this is our position, so we're gonna say P meter. This is T, or we can say X for position. Okay, so that's that. Let's do the another one for velocity and time. Velocity and time. Okay, so 10 unit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, why should we do 10 every time? Let's do 12, 11, 12. Well, let's do 2 more, 14. Okay, so let's do this time let's do 2 more. Then why should we keep having negative 1 downstairs? So this is say 0, this is negative 1, this is negative 2, this is 1, this is 2, and this is 3. Okay, so now let's make those rectangular box. And how many? 14 of them. Okay. All right, we're done. So this is our velocity. Velocity, and velocity is meters. And this is our time. Time is always second. Okay. Let's make the last table. Last table is 14 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And just like this one, because this would be the reflection of that for acceleration, velocity and acceleration. So minus 1, minus 2. Well, minus 1 and minus 2. So this is 0, this is 1, this is 2, this is 3. All right. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14, right? This is 1, 2, 3. So as I said, this would be acceleration, meter, this is time, second, right? Great. Well, there should be another line. Can't miss that. Let's see. Let's say a car starts from 2 meters and then moves to how many seconds? 1 second, 2 seconds, and then 3 seconds. Okay, and then it goes up. How many meters? 2 meters, I guess. And then it goes down just 1 meter, and it goes forward to, I guess, let's say 2 meters, and it comes back all the way to 10. Okay, so a car moves toward the east 3 seconds, and then well, a car moves this way and then go up. Okay, so what can we find? Number A, we can find, I guess, displacement, let's say, displacement. Number B, we can find, I guess, velocity. Number C, we can find entire displacement from here to here, displacement entire area, and the velocity entire from here to here. Yeah, so let's put a box here, I guess. Well, let's put, to save the space, let's put displacement for D, and let's put velocity for B, and D entire area, B entire area. Let's save a lot of space. Okay, so let's make a box. 1, 2, 3, 4, and 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Okay, so let's see. What is the displacement here? Okay, so displacement is d2 minus d1. What is the x2 minus x1? x2 is 2, x1 is 2, displacement is no displacement, 0. What is the displacement here? 4 minus 2, x2 is 4, x1 is 2, displacement is 2. What about here? Here is, I'm not going to do everything because we already did it enough, so you should be able to understand. This is x2 minus x1, x2 is 3, x1 is minus 4, so minus 1. Here the displacement is just 0 because 3 minus 3 is 0. Here the displacement is what? Negative 1, negative 1, x2 is negative 1, negative 4. So it's going to be negative 1 and so it's negative 1, negative 3, negative 3. So negative 3. So it's negative 4. Okay, so velocity is just displacement over time, change of time. So no matter what is the change of time, if the displacement is 0, velocity is 0. What about this one? 4 minus 3 is 1, 2 divided by 1 is 2. What about this one? 7 minus 5 is 2, 2 divided by negative 1. Well, okay, so this is negative, okay, so this is negative 1 divided by 1, which is negative 1. This is 0 divided by 2, which is 0. And this is 4 divided by 1, 2, 3, because 10 minus 7 is 3, 4 divided by 3 is 1.33 minus 1.33. So the total displacement is 2 minus 5 is minus 3, and total velocity is minus 3 over how many seconds? 10 seconds. 10. Okay? So this is total displacement, this is total velocity. Now let's do this part. What is the difference? This is position, this is time, this is velocity, this is time. This is pretty simple. That's why I'm not gonna I'm not gonna go in details because we already did difficult question than this one. So let's say a car starts from 1 and come here and then move 2 units and then go 1 unit and move 2 more units and come all the way to, all right, let's put some unit here. This is 1, this is 2, 3, 4, 5, 6, 7, 9, 11, 13. Okay, so maybe it comes all the way to the 11 and then it's go this way. Okay, so let me erase this. This is not part of the question. Okay. So let's put this one too. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. Okay. So now what question are we going to ask ourselves? Let's find the velocity, average velocity, number 1. Number 2, let's ourselves acceleration. Number 3, let's ourselves ask displacement. Number 4, let's ask ourselves displacement entire region. 5, displacement, velocity entire region. Number 6, let's ourselves ask object reverse. 7, object at rest. And then 8, acceleration versus time. Okay, so let's make this box again because box become very helpful. So 1, 2, 3, 4, 5, 6, 7. All right. So now 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay. So what is the velocity of this one? This one, okay. The velocity of this one is 2 plus 1, 3. 3 divided by 2 is 1.5. Average velocity. The velocity of this one is x2 is 2, x1 is 2, 2 to 4 times divided by 2 is 2. And then this one is 2 plus 3, 5. 5 divided by 2 is 2.5. And then this one is, just okay, this one is 3 plus 3 is 6 divided by 2 is 3. This one is 3 minus 2 divided by 2 minus 1 divided by 2 is minus 0.5. Minus 0.5. And the last but not least, negative 2, 4 divided by 2 is negative 2. All right, so, okay, so the acceleration is delta V over delta T. Okay, so delta V over delta T over here, which is 1.5. This one is acceleration is 0 because car is not the car is not accelerating. See the straight line. When you see straight line, it is 0. Then the next one is just 1 because 3 minus 2 is 1 divided by 1 is 1. And the next one is 0 again. And then we have minus 1.25. Why? It's pretty simple because x2 velocity, x2 minus 2 minus 3 is minus 5 divided by the change of time, which is 1, 2, 3, 4, and which is negative 1, 2, 5. And the final one is acceleration is 0 over here because there is no change. All right. So displacement is okay. This one is going to be kind of interesting because we're gonna do the area under the curve, which is length is 2, width is 1, 2 times length is well, okay, so length is 2. Okay, here from 0 we're gonna do it 0, so length is 2, width is 2, 4. This is gonna be this subtract from 4, take away from 4, so it's gonna be 3. The next one is, so length is 2, width is 2, so 4. This one is, okay, length is well, let's see, length is 1, width is 2, so width is 3, 1, 2, 3, so 3 times 1 is 3, but there is something missing here. You subtract that one, so you get 2.5. This one is pretty simple. So 1, 2, 1, 2, 3, that is just simply 6. And this one is also simple. If you calculate that, it will be just 2. And whatever this one, 1, 2, 3, this one, 1, 2, 3, 1, 2, it's going to be 6, but negative. Why negative? We should already know, because as I said, I'm not going to go in details. We did this thing before. So distance, displacement, the entire area is 7, 8, 9, 6, 9, 15, 17.5 minus 6, which is 11.5. The velocity of the entire area is just 2, 4, 7. Right, so velocity of the entire area is 11.5. We can write 11.5, right, divided by the whole time from here to here is 14, right? Now let's say object at rest. Object at rest is the object is, you look at here, object is just from here, and then at 0 it rests. Object is rest is here is 9.5 something, 9.5. Object reverses position. Object reverses position is from here down. Object reverses position, and the acceleration versus time is, let's do that. This looks wrong. So this is 0. Let's say this is minus 0.5. This is minus 1. This is 0.5. This is 1. This is 1.5. Okay, and this is 2. All right. So let's see. What is the acceleration? What was the acceleration? What is the acceleration from 1? What is the acceleration from time 0 to 2? 1.5. So 1.5. 0 to 2. 0 to 2. Acceleration is 1.5. All right. So from 2 to 5, acceleration is 0. So 2 to 5. 2 to 5 acceleration is 0. 2 to 5. 2 to 5 acceleration is 0. 2 to 5 acceleration is 0. So 0. So one acceleration is 1 from 5 to 6. From 5 to 6 is acceleration is 1. And then from 7 to from 5 to from okay, right. All right. So acceleration is 0 from 5 to 7. Acceleration is 0. So from 5 to 7, 4, 5, 5 to 7, acceleration is 0. All right. And then the acceleration is 1.25, negative 1.25 from 7 to 11. Negative 1.25 should be somewhere here. Okay, so negative 1.25 from 7 to 9, from 7 to 9. This is acceleration. And the last is from 11 to 13, acceleration is 0. From 11 to 13, acceleration is 0. 0 is right here. Acceleration is 0. So that's that. Now we can do our last math problem, but I think we will do it on the next video, because we don't, I guess, have enough time to complete that problem. All right, so let me erase that. I have just one question left.